The absence of a body is no longer a mystery, it's a clue. If you build a machine and the manual is lost, later people will call it an altar. Transition, resonance without materials is just sound. For a system to transduce, convert one kind of energy into another, the stuff has to matter. And here, the rocks aren't generic. They're chosen like parts off a spec sheet. The material science clues. Stakes, materials tell intent. Builders pick stone the way engineers pick alloys, by property, not poetry. If the choices cluster around behaviors that couple pressure, water, and vibration, then we're looking at design logic, not quarry convenience. Action, start with granite from Aswan, rosy and hard, loaded with quartz and feldspar. Quartz isn't just pretty, it's piezoelectric. Squeeze, strike, or flex it, and you get an electric potential across crystal axes. In bulk granite, the crystals are randomly oriented, so you don't get a clean battery. But under sustained vibration or pressure cycling, local charge domains appear and vanish, creating fields at interfaces. The king's chamber walls and beams, massive granite, store elastic energy and return it efficiently. The sarcophagus, same material, becomes a small, high-Q resonator. High quartz content gives you stiffness and low internal damping, which means energy stays coherent longer. Then limestone. The casings from Tura were fine-grained, bright, low porosity, good exterior skins that reflect heat and shed water. The core limestones on the plateau are more heterogeneous, but the base sits on limestone bedrock with predictable bedding planes and capillary behavior. Limestone is also a decent dielectric, an insulator. Sandwich granite inside limestone and you've separated conductive domains with insulating layers. That's a recipe for building up field gradients if mechanical stress is rhythmically applied. Dolomite layers show up. 2, magnesium-rich carbonate rock harder than typical limestone. Some courses in the Great Pyramid contain dolomitic stone. Why? It's more abrasion-resistant and changes how surfaces wear or transmit micro-motion. In a stack where certain layers interface with moving plugs or experience stress concentrations, dolomite's mechanical properties make sense. You place it where you want reduced wear or altered friction. Now water. The plateau isn't dry stone above a vacuum. Groundwater moves through joints, especially seasonally with Nile levels. Moisture in contact with limestone raises ionic conductivity. Microfilms along bedding planes become conductive paths. If pressure cycles drive water in and out, you get streaming potentials, electrokinetic phenomena where fluid motion drags charge along mineral surfaces. Combine that with piezoelectric microcharges developing in flexing granite, and interfaces come alive electrically. No glowing arcs, just fields and slow charge drift that can bias other processes. Impact, viewed together, you get a stack that's mechanically strong, acoustically lively, and electrically interesting under stress. Granite concentrates and returns vibration. Limestone confines and insulates. Moisture modulates conductivity. Dolomite protects critical surfaces. If you were prototyping a passive transducer using geology, this is the bill of materials you trial, hypothesis, not conclusion. Complication, copper. People expect copper everywhere if this were an electrical machine. But copper corrodes fast in wet ionic environments. You see remarkably little surviving copper beyond small fittings, those tiny handles on the so-called Gantenbrink doors, occasional clamps, and presumed tool remnants. Instead, we see bedrock, stone plugs, and polished interfaces bearing the brunt. That suggests a system leaning on mineral and structural effects rather than metal wires. A low-frequency, high-mass device, not a spark thrower. Ware tells another story. The plug block grooves are polished where sliding happened under load. The antechamber slots are burnished at repeat contact points. The floor recesses show crisp edges in some spots and rounded wear elsewhere, like feet of heavy stones seeding and receding. If you ran thick oils or slurries through here, you'd expect residue. You don't see oily films, you see mineral polish, consistent with stone-on-stone motion and periodic pressure. Meanwhile, the bedrock cuttings under the pyramid, the so-called subterranean chamber and its trench interact with groundwater. It's a space where pressure could accumulate and release through a narrow passage, driving low-frequency pulses. Water compresses slightly, gas compresses more. A cavity with mixed phases becomes a spring. Drive it with seasonal water table changes, and you've got a big, slow oscillator feeding higher frequency harmonics upstairs through the geometry. Granite upstairs will hear that and ring. Let's handle the geopolymer detour quickly. Some argue many blocks were cast, not carved. Whatever the case elsewhere, the king's chamber blocks and beams are quarried granite. Petrography confirms crystalline fabric and feldspar grain boundaries that don't match cast stone. The sarcophagus shows tool marks consistent with saws and abrasives on igneous rock, not cast surfaces. So the core functional elements are definitely natural granite, chosen and finished, not poured. Human moment: an engineer who maps stray fields for a living took a handheld M sensor into limestone tunnels in another ancient site and watched the baseline wander when foot traffic shook the floor. He shrugged and said, "Rock is noisy when you kick it." Now scale the mass up and the coherence in. With the right geometry, noisy becomes structured. Impact materials align with the resonance plan. Granite gives you elasticity and piezoelectric micro effects. Limestone shapes boundaries and manages moisture. Dolomite hardens where motion happens. Bedrock and groundwater provide a seasonal driver. This isn't a religious shopping list. It's an engineering palette that supports a passive, low-frequency machine that could condition energy, pressure to motion, motion to field, field to what? Maybe nothing we can plug an appliance into. Maybe something biological, environmental, or communicative. But the choices are too on brand to be random. Complication: if that's true, why no copper coils, no iron cores? Because you don't need them for the regime in question. At infrasonic and acoustic frequencies, mass and shape do the heavy lifting. Metals would corrode, detune, and telegraph intent. Stone is durable, stable, and public. You can't loot a field gradient or steal a standing wave. Transition: if a machine runs, it outputs something. If materials and geometry support transduction, then where does the conditioned energy go, or what does it do on site? The answer might not be a wire, it might be a landscape. False ending 1. The "it's just a tomb" defense collapses. Let's give the orthodox story its best day. A pharaoh dies, the state mobilizes. They raise a mountain of stone to guard him, orient it to the sky to bless him, line secret passages with deterrents, seal it forever, and wait for eternity. Clean, familiar, comforting. Now hold that picture against the evidence. A tomb explains mass and spectacle, but it stumbles on precision where nobody could see. If this is only about presence, why are the interior passage angles so exact and the chamber dimensions so fussy? Tombs ask for symbolism and security. This asks for calibration. You don't grind joints that tight and tune cavities that narrow for a one-time funeral. The defense leans on security: granite plugs, portcullises, hidden shafts. Fair. But security devices don't need polished guideways that show repeated motion or floor recesses that look like staged stops. They don't need switchable shafts with fitted stone doors capped by copper hardware. You seal once and you're done. These features behave like controls, not props. Then there's the soot problem. A tomb expects long preparation under lamps and a funerary entourage with torches. Yet the ceilings aren't lacquered with carbon. You can invoke clean-burning fuels and mirrors, but the chemistry and the optical losses won't carry thousands of worker hours underground. A ritual narrative has to smuggle in engineering to make the ritual visible. That's backwards. What about the sarcophagus? Surely that anchors the burial. Except it's an oversized, rough-finished granite box, acoustically lively, closely matched to chamber modes, and larger than the passage that leads to it, meaning it went in before the chamber was sealed above. No inscriptions, no royal cartouches, no gilded fit-out. It rings, it doesn't read. Orthodoxy points to the relieving chambers, classic load mitigation. Correct. But 5 stacked tiers of massive granite beams don't just relieve, they set boundary conditions for vibration. Their spacing and bedding shape how the king's chamber stores and releases energy. A funeral needs weight redistribution. A resonator needs that plus control. Here we get both. Inscriptions, absent where you'd expect them most. The walls are mute. If looters took grave goods, they didn't sandblast prayers off granite. Silence in a culture that wrote on everything sacred is its own statement. Function sometimes keeps surfaces clean because text is contamination. That logic shows up in labs and instruments all the time. The cleanest test is predictive power. It's a tomb predicts seals, symbolism, and a body. We see seals used like valves, symbolism that keeps shrinking under measurement, and no body. The machine hypothesis predicts tuned spaces, controllable pathways, material choices that favor resonance and pressure management. We see all of that. Here, S where the neat bow tries to tie. Maybe it's both. A tomb that just happens to be an acoustic marvel on a geologic sweet spot with materials that transduce and features that switch. That's a lot of just happens. And then one more thread snaps the bow, the external alignments. If this were an isolated memorial, its relationship to other sites could wander. But the azimuths to Heliopolis, the triangulation with Abu Rosh, the cardinal exactness, all of it behaves like a node keyed to a larger layout. Tomb logic doesn't need a network, a system does. Because the pyramid wasn't alone, it sat in a circuit. The alignment network. While all that was happening inside the stone, something bigger was happening across the landscape. Stakes. A single tuned structure is intriguing. A coordinated layout is intention at scale. If Giza talks to other places by angle, geology, and water, we're not looking at a mausoleum, we're staring at nodes in a system. Action start with what we can measure, not what we can mythologize. The Giza complex is locked to the cardinal directions with uncanny accuracy. That alone doesn't prove a network, but watch how the site relates to Heliopolis, the old sun cult center. Draw a line from the Great Pyramid's apex to Heliopolis, and you're tracing an azimuth that anchors the plateau to a long-standing religious astronomical marker sitting on different ground. Extend another line northwest to Abu Rosh, where an unfinished pyramid sits on higher, harder strata. Now you have a triangle, Giza, Heliopolis, Abu Rosh. It isn't random. The vertices sit on distinct geology, varying bedrock hardness, different relationships to the Nile's floodplain, and unique groundwater behavior. Why those conditions matter? Machines don't float in abstraction, they sit on materials. The Giza Plateau's Makatam limestone provides a stable, elevated base with manageable fissures. Heliopolis lies closer to alluvial zones and historically to ritual timing, solar, calendrical, observational. Abu Rosh occupies a ridge with different resonance and drainage. Link nodes with clear lines of sight and consistent bearings, and you can synchronize states. Open a shaft here when pressure peaks there. Take a reading when the sun hits that marker and know your geometry and timing haven't drifted. Meanwhile, within Giza, baselines tie the three pyramids into a pattern that's far tighter than folklore suggests. We don't need Orion to see it. The center lines, causeway azimuths, and placement relative to the Nile's ancient bend set fixed references. The causeway of Kafr trends toward the west-southwest, crossing a slope that forces precision if you don't want your angle to wander. Builders kept it clean. That's a surveyor's signature across terrain. Impact, when you reproduce cardinal exactness, triangulation to known centers, and robust sighting on specific strata, you've built a platform that resists seasonal slop. Floodwaters rise and fall, but your references persist. The machine upstairs, the resonant one, depends on that stability. It's not just straight lines, it's straight lines rooted in dependable ground. Now let's widen the frame carefully. Across the world, step away from legends and check what's repeatable. Many major pyramidal complexes prioritize cardinal alignment. Teotihuacan's main axis is offset from true north by a consistent angle, but its buildings key to that grid relentlessly. The Xi'an pyramid mounds in China sit with sides trending to the compass, even as their earthen forms blur. Parallel priorities appear. Control orientation first, then layer meaning. We're not claiming direct connections. We're noting convergent engineering where alignment matters before decoration. Complication, ley lines creeping fast. We're not going there. The data that survives scrutiny is geodesy, the measured positions, azimuths, and site-to-site bearings that can be checked with satellites and total stations. If two places share a cardinal obsession and sit on geology that aids stability or resonance, the safest claim is shared design logic, not a magical meridian. Keep it falsifiable. Does the orientation hold within small error bars? Does the bedrock change the way a structure couples to the ground? Can groundwater pathways be mapped and compared to placement choices? If yes, there's a functional rationale. Meanwhile, the Nile bend. Ancient courses wandered, but the Giza Plateau remained an island of rock above the mess. Place a system there and you can sample or exploit seasonal water without being swallowed by it. Heliopolis, downriver, sits where observation and procession met. Timing, not heavy mechanics. If you want a network that turns seasonal pulses into coordinated operations, you put your tuner on the high, hard place and your clock where the sky can be read cleanly. That pairing isn't mystical, it's operational. Human moment, a modern surveyor stood on the Great Pyramid's southeast corner with a GNSS rover and squinted along the base. He said, "They could see their errors the same way I do, by walking the line at dusk." Light graced the face, tiny shadows betrayed bumps, and he smiled. If your neighbor pyramid shares your north within a few arc minutes, somebody taught both teams the same trick. That's institutional knowledge spanning projects. Impact, a network view reframes dozens of site features. Causeways become transmission lines for timing, ceremonial on the surface, but physically locking bearings across distance. Valley temples sit at the interface between alluvium and bedrock, gateways where water, people, and perhaps pressure interact. Smaller pyramids and mastabas align to the big axes, keeping local construction phase-locked with the master grid. Even minor deviations can be read as corrections for local terrain, not sloppy execution. Dress the Orion debate briefly. The belt star overlay is seductive, but the strongest parts of that claim don't survive rigorous tests against high-precision surveys and precession models. We don't need it. The terrestrial geometry is enough. North-south discipline, functional triangulation, and geology first sighting. Ritual may have adopted stellar stories later to explain choices already made for physical reasons. That's how cultures metabolize machines into myth. Complication that matters. If this was a grid, it likely switched on and off, seasonally, ritually, practically. You'd expect markers or alignments that help operators know when to engage. Solstitial sunrises throwing lines down corridors, heliacal risings pegging calendars, shadows confirming axes, observable cues that double as public theater. The network survives because its checkpoints are in the sky and on the ground, not on a scroll. Everything was about to change when the river rose. Water pressure and the pulse. The plateau breathes with the river. That's the quiet truth locals know, even if maps don't show it. Stakes first. If seasonal water shifts create pressure pulses under the pyramid, then timing isn't ceremonial, it's hydraulic. A driver that's steady could have powered cycles in the stone without a single torch lit. Action head below the polished geometry to the rough cut, the subterranean chamber and that strange, narrow trench leading to a dead-end crawl. It's not pretty, but the shapes matter. The chamber's irregular vault and the low passage act like a spring and a valve. When the water table rises with the Nile's annual flood, microfractures in the Makatam limestone admit moisture. Pore spaces saturate. Pressure builds in the joints and relieves as levels fall. That fluid movement doesn't roar, it nudges. In a sealed cavity, even small volume changes can produce measurable pressure waves. Now imagine the narrow cut as a quarter-wave tube at infrasonic frequencies, one end closed by rock, the other coupled to a larger cavity. Pressure pulses from groundwater seepage would excite it like breath across a bottle, except the breath is the river and the bottle is stone. The pulses climb the geometry step by step, trench to chamber, chamber to passage, passage to the vast mass above, where granite waits to hear ground-borne motion and answer with its own preferred modes. Meanwhile, look at floor details in the upper antechamber, polished beddings, recesses that seat blocks in stages. If a cycle needed throttling, on during peak flood, off during dry, those features let operators change the system's state without rebuilding it. Open a shaft cap, lower a portcullis, seat a plug deeper to adjust the flow path. A seasonal switchboard in stone. Impact timing follows the river. Operators wouldn't need precision clocks. They'd need observation, watching the sun at Heliopolis, feeling the rise in the Valley Temple, reading damp lines in bedrock. The pulse becomes predictable. The plateau inhales in flood, exhales in drought. Use it to prime resonance upstairs, and you've turned a landscape into a metronome. That makes the network practical. You aren't aligning myths, you're phasing machines to the same beat. Transition, which raises the human problem. Who maintained a system that intimate with geology? We've got the outputs in stone, but almost no story about the people who tuned it. Capability without biography is a warning sign of knowledge concentrated in a few hands and easily lost. The builders, capability without biography. We meet their work everywhere and meet them almost nowhere. Stakes. When a civilization's highest skill lives in muscle memory and guild practice instead of books, it can vanish in a single bad century. The pyramids suggest an apex of process control, but the record doesn't give us a textbook, a manual, or even a clear job title for the person who signed off on tolerances. Action, we can piece the organization from scars and leftovers. Workers' villages, bakeries, medical areas, evidence of a cared for labor force that wasn't enslaved in chains but drafted seasonally, fed well and organized. That explains throughput, not precision. The tight work rides on specialists. Tool marks tell us they used copper saws and drills with quartz sand as the cutting grit. That part's straightforward. What's missing is the how many passes, how to check flat, how to reject. Those are procedures, not tools. Survey logic peeks through in the layout. Right angles on the base corners with errors measured in arc seconds don't appear because a single foreman eyeballed it. That implies a cadre of surveyors using Merkits, plumb lines, and baselines stretched and checked against stars. Night work matters here. A duty cycle emerges. Measure under sky, cut and place by day, remeasure at dusk. Someone dictated that cadence, protected it from political interruption, and enforced rework when numbers drifted. That's institutional discipline. Now the granite beams in the relieving chambers. Quarrying at Aswan, moving upriver, staging on the plateau, logistics woven into ritual calendars so flood transport and manpower peaks align. You don't hit those windows by accident. A scheduling brain sat above it all, translating river cycles into building phases. We don't know the name. We can read the choices.